So the statement which is there is diatomic elements. So these elements on that table, can you all see the table, guys? And
Yes, we can.
Yes, sir.
okay. So all of these in this table exist as diatomic molecules. So meaning in nature, a hydrogen atom bonds with another hydrogen atom to form H2, and that's how it exists. The same case with nitrogen, oxygen, up to iodine. Have you seen astatine on your periodic table? And guys, astatine on your periodic table.
Is it possible to have a target receiving or bus?
Nine guys.
No.
Have you seen
No,
astatine? Guys, I'm asking to say, have you seen astatine on your periodic table? Now to come office, guys, have you seen astatine on the periodic table? I'm asking.
I've seen it, sir.
It's in what group?
It's in group 7.
But have you seen that it's not on our table?
It's not there.
Why? Because astatine does not exist in nature. But I'm going to go to now. I'm discuss a target. When I'm going to Papa Facebook, you want enough for the target. Oh. Yeah.
That's what you're consuming.
Eh. No puoi fare la grafica da cash.
Oh,
So guys, I was asking. So that astatine does not exist in nature. So if you found it in an equation, but you should always assume it as diatomic as well, though it's not on our table. When we listed the elements, we said that there are certain elements that have transitory existences, and astatine was one of them.
Madam.
So you must reason like that. So that is the case. So what do we mean when we say these exist as diatomic elements? It's that when you hear hydrogen, oxygen in an equation, when someone says oxygen reacts with methane to form carbon dioxide and water, that oxygen should always be the oxygen should always be the O2. So even when someone says oxygen and hydrogen react to form water, the oxygen should be O2 plus H2, giving you H2O, and then you balance. The mistake that people make is they don't understand what it means to be a diatomic. So nitrogen, you can find someone asabika ka NK ka keka. These ones that are here, even when someone says chlorine plus sodium, giving you sodium chloride, the sodium will just be Na, but the chlorine should always be Cl2. Their colors at room temperature are stated. Can you see the screen here?
Yes,
guys, can you see the screen?
Yes, sir.
There's a question? Is there a question? So that's what we mean. So you must understand that these things are very important, like the oxygen. So it's almost everywhere. So if you hear say oxygen reacts with copper, then the oxygen is O2. Please do not make a mistake. So meaning there are two categories of elements. Some elements are molecular, the ones that are diatomic. There are even those that are tri-tetra polyatomic. Like sulfur forms a lot of complexes. You find S4, S8, all those are molecular forms of sulfur. But then there are those that exist only as atomic, e.g. argon, copper. When you have it, when you write it in an equation, you must write only the symbol that you see on the periodic table. So those are the things that are there. I gave a task and I'm impressed with your responses. So 5 elements that are metals, it's very easy. So many of them that are metals, you know them. 2 that are liquid at room temperature, and there are only 2, which is mercury and bromine. So if you want to be in safe mode, you can go on the transitional elements to get the metals there, or the group 1, group 2. Group 3, there are also metalloids there, so you must be a bit careful. 5 elements that are gases, except that are not mobile gases, you must remember hydrogen, oxygen, nitrogen, chlorine, fluorine. That's how it is. These you can also state them at room temperature. Remember that room temperature is a range from 20 to 30. So if the textbook says 20 degrees or says 25 degrees or 30 degrees, all those are room temperature. Although the most that we pick out is 25 because it's an average. But even 20 degrees is okay for room temperature. Because as you know, even our weather guys, mnamunaira change. So identify a metal, a non-metal, a metalloid, you can do all that. So these are the last things that I can mention. The last one I think I should talk about is what is called electronegativity. Have you ever heard of that word? First year. Mariumvapo electronegativity.
No, sir.
You've never heard it from your secondary school? Electronegativity. What's that? Have you ever heard of electronegativity, guys?
No.
No, sir.
You've never heard of it?
No, sorry.
Seriously?
Yes, sir.
Okay. So, guys, electronegativity is the tendency of an element to accept electrons. The tendency of an element to accept electrons, or the ease with which elements accept electrons. So meaning those that easily accept electrons, especially the non-metals, they are very electronegative. They are very electronegative. So anything that easily accepts bonding electrons is termed as electronegative. So as you move on your periodic table, in the period from sodium to chlorine, as you move from left to right, the electronegativity increases, because as you go that way, the elements become more non-metallic, we can say. So as you move from left to right, the electronegativity increases, meaning chlorine is more electronegative than sodium. What that means is that chlorine can accept electrons, while sodium would easily donate. So meaning sodium is electropositive. Then as you go down a group, the electronegativity decreases because elements down the group, when you're going down the group, they become more electropositive. So those are the things that you must reason. So now what I want to tell you is that you should go and look up, what word is that? I want you to go and look up ionization energy. I want you to go and look up ionization energy. Don't worry, I'll put these terms there. Apart from the amber, we should look at the periodic table nicely. But then I'll put these terms that I've put there. I'm not expecting you to swat them. I'll put them there. So now, guys, remember that when you're talking about elements and their states, you must know them, because when you're writing like equations including state symbols, for calcium you put S for solid. I'm sure you know that. For nitrogen, which is N2, you put G for gas. So those are things. Reason like that. The temperature is very important here. If say the equation is taking place at 400 degrees Celsius, if you're not in the lab, the person who pelele question if we look up on state symbols, because at 400 degrees Celsius, sulfur and iodine, which are solid at room temperature, by then they would have even boiled off. So maybe there will be gases. So you should reason like that. Please, please, please. Are there any questions? Sorry guys, much very ashot wa mukali twa munene puka tatwisa isa kunchitwefu fundira mumayanda. So ipara machva wakachongo ni joy yakumonana. One upange chongo ni nebo sona badaba timu class of ya mweka dikaziso mwadishi bafu. So now that's the thing. Any questions?
Sir,
Yes, mama.
the way question 1 is, why you have to, should all the answers be being, you just have to put the state symbols, or why? If you
No.
put
The practice one, you just say the names of the symbols of the elements.
Also, if you put the name, then you fail.
Okay, the question says write the chemical symbols for. Namu for mammy.
Yes,
Like the chemical, like wakupera nganga yakupera omutyachi uyu wakusambele wanu. So kukonga question of foil. Imagine now yakunganga elba kwati uyu mutinga wasamba fye nishwa beola elo wanu. Nishwa rufyani. Mambo guys. So even oxygen, like guys, I'm sure you know the oxygen. The one you claim, no, you're my oxygen. Whatever, you're my oxygen, I can't survive without you. That oxygen you talk about is O2. The one we breathe is O2. The oxygen that is vital for our lives is O2. Ozone, which is O3, is even poisonous. It's a very strong oxidant. It's poisonous. But the oxygen, which is O2, is very nice for our bodies. You're my oxygen. Obviously, you've heard that song. You're my oxygen. So you are claiming I can't breathe without you. Means you have loved that person. My mother. So always know that these elements are diatomic. No one will tell you this one is diatomic. You should reason on your own. So when you just see fluorine, remember, was it diatomic? Yes. Then it's F2 in the equation. So that's the expectation. Remember, you're only practicing this so that you boost your own confidence. It's not necessarily part of the continuous assessment. And it's also proof that lessons are taking place. And we must know that learning is taking place. What else? Who else has a question? Mulubira. Molovila. So the next topic, which I'll spill over to the next, because I'm supposed to chill. The next topic is we'll look at compounds and formulas. Formulas is American term. What we should actually say is formulae, which is British English, formulae. So we'll spill it over to the next. So what are the key terms? Your job is to distinguish between molecular and ionic compounds. So remember we defined this earlier. We said that molecular ionic compounds are formed when a metal reacts with a non-metal. So when you have a metal and a non-metal, then you have an ionic compound. A molecular compound, and it involves the transfer of electrons from a grade 8, you did that, involve the transfer of electrons. Then the molecular is where there's a covalent bond, the bonds that involve sharing of electrons. So now, when you have a covalent bond, then the bond there and what are formed are called molecules. Although the keyword molecule has been coined to mean the simplest of the compound. Like say, if you have sodium sulfate, ionic compounds are not molecular, so you cannot call ionic compounds molecules. But you find someone is telling you a sodium chloride molecule. Like here, but generalized to make it easy to understand. Like the smallest of a compound has been deemed as a molecule. So those are the things. So key terms, you'll be able to define a compound. Then next, a molecule. Remember, a compound is when two or more elements are combined. Yeah? So if you have two or more elements in definite proportions, you go and look those things up. Molecule, the smallest particle that exists independently, the smallest uncharged particle of a compound, like H2O. H ama H yabiri na O imo. That is a molecule. The H2O, like the one you see in the equation, the ones we write in our equations are molecules, because we write the simplest at atomic level. Even when you have 10 grams reacting or 20 kg reacting, as we write the molecule H2O. Then you have ions. Remember, ions are charged atoms. The negative ones are anions. The positive ones are cations. Go and look up all these terms, because what I want is for you to ask me questions muri 10 minutes. It should be participatory learning. Nishikuelendesa veneka na data. Na imwavene mwalikwata data. You have a background. So we need to be participating. If I'm the only one ule isuka nishipadi obwafi. Nga ne ule isuka ni nebo fineka nishipadi obwafi. All of us have to participate. I'm sure you are getting. Mampa guys, eh? So I'll leave this time for questions where you are not clear on elements, so that when we move forward, I know e-learning is not effective, but it must be effective with this effort we are putting in. We must try to make it effective. Any question? Any question, guys? Robert, is there a question? Robert?
Not yet. I'm just trying to gather up.
You are trying to
No question yet, sir. But I'm trying to I'm trying to analyze what you're actually saying. So if I have a question, I'll definitely ask you.
Okay.
I'm trying to analyze what you've just said.
Ah, my friend, what's in more reporter? Wamba kumove TV. Urefu mano mwenda wa ma reporters ga. Any other question? You can use your hand, start at the IC. Because as you can
There
see,
are two types.
I've shared the screen. And guys,
Compound and formula.
huh?
Introduction. Compound.
Huh?
Sir,
Yes.
sir, I wanted to ask about the diatomic.
Who is this? Mule mia kwa maboko. Hapa ni nishita nani? So when I respond, I answer you by name.
Queen, sir.
Yeah?
Queen.
It's who?
Queen, sir.
Okay, Queen ni Mwanya.
Yes, sir.
Okay. You wanted to ask about what?
I wanted to ask about the diatomic.
Yes.
Sir, where there's oxygen 2, chlorine 2, fluorine 2. I mean, those two, that simply means that diatomic.
Yes, that means.
So,
that.
for example, we have been asked. For example, we have been asked where the 2 comes from.
They are molecules. Like I said, some of these are molecular, some of them are atomic. Meaning, oxygen in nature bonds with another oxygen covalently to form the O2. So it's molecular. There's a molecular bond between 2 oxygen atoms. That's what we mean. But the most important for you now, Queen, is to know that whenever someone says iodine is produced or iodine reacts, you will I come up because the I. You will remember that iodine in nature exists as a diatomic element. So what you write is I2. Are you getting it? We will say words like oxygen, but what you write is O2. We will say like chlorine, what you write is CaO2. Are you getting it?
Yes, sir.
They are covalently bonded. Like the same way water molecule, in a water molecule, oxygen and hydrogen are bonded. That's how the oxygen atoms also are bonded. They share electrons together, and that's how they exist as a stable oxygen. There was a hand, Futi Aluba. Who is it that raised their hand? Guys.
It's me, sir.
Now?
Is silicon a metal or non-metal?
Silicon. It depends because silicon is a metalloid.
Yes, sir.
Silicon is our team, a metalloid. It has properties of metals and non-metals. Is this lucky?
Yes, sir.
Okay. So it has both properties of metals and non-metals. So in some cases you find it's reacting like a metal. In some cases it's behaving like a non-metal. So the best just to say it is a metalloid. On the list of metalloids, it's there.
All right, thanks.
Yes. Any other question?
Sir. How can you define what is subscripts?
Chua kalondula fika subscript. Gawalemba filati H2O. Now what H2O there? Ka2 ni ka subscript. A number which is written below a number.
Okay, so
Yes.
in the case of where it is like in front there's 2, and then you write H and then 2 below. The one that's in front is also a subscript.
No, Mayo, Ninda Ndakade, is plus punch O2 katuka like a subscript. H2 a subscript. So very compound, Musango Tama subscript. That's the reason why we're trying to say that. If a pantashi omranda nishi will balance equation, will balance equation no avika pachi plus 2H2O. Tevo? 2H2O. The 2 is a coefficient ya pantashi. Namufamaze. Mwali sambile na musugo a coefficient. One number 2x. You must about find the coefficient of x. Try the proof there. Tamasangile po. No try the proof. So the things. So the subscript is the small number that you write at the bottom. Kafide kamuli fonti no. So that's the meaning. Takafide kamutwalika no mtu atinamu ya mkusambia subscript. Ngana makonfa nikawe tikamutsungu. Momfa mayoba. Is this Mulubira?
Mapalo.
Mapalo again. Eh? Mulubira, you raised your hand. Mulubira. Hey. Mulubira. Yeah? Fine guys. Tamukwete. So the most important guys. Masa. Uncle. Nani mustahil? Okay, then na signal game. Good, nasa mustahil. Okay, chess. Okay. Guys, tamukwete vyakulanda. So importantly, guys, I want to emphasize today we've identified these elements. Practically, what you don't see the H to the what? Someone just say a reddish brown liquid was formed. Then you know that in bromine in gas. One person has raised the hand. Jacqueline.
Yes, sir.
Yes.
Sir, I had a question that when you post a practice on study master, does it mean that we all have to contribute, even other students have given a correct answer?
All of you
it's okay.
should participate. All of you should participate. Okay, that's how it shows that you've been active in class. Okay? Clopas.
Yes, sir. I wanted to find out if those the atomic elements. What happened to the valences when they react with a metal, especially those which are non-metals, they react with a metal.
When they react now, there'll be a rearrangement of the atoms. So now when they react with a metal, it will just be sodium and the oxygen atom. The diatomic part is just how it exists, how to enter the reaction. But when they start reacting, it will just be sodium and oxygen, and how many you expect to react with it. So please don't struggle so much. So when you start bonding, you deal with elements alone, not the fact that they are diatomic or monatomic. So that's the reasoning. Don't think can be either as H2 either in to react. No. How it will react? It will react as an element reacting with another element. That's why if you can see we are interchanging, we're saying diatomic elements, diatomic molecules. So whenever a reaction is taking place, there's rearrangement of the structures there. So that's the case.
All right, sir. Thank you.
Sharp. Mulubila, your mic it's on. Mukwanya. I was saying your mic has been on for some time. Okay, guys. So go through this. More especially go through compounds. Then we'll come and talk about these things the next time. Continue to go through. Fight as hard. Ask as many questions. I'll send the PDF file later. Enjoy your day, guys. Take care of yourselves.